So hello friends, after a general intro into solar observing and a video about calcium observing, I will today make my first video about H-alpha, which you can see here on the title page. This one is not by me, and this one I made recently. So with H-alpha we are seeing mainly the chromosphere of the Sun. And the chromosphere is really interesting because lots of things are happening there. It looks different almost from minute to minute. So the Sun is really cooking in the H-alpha. These are some telescopes to observe H-alpha. Some cheaper ones, some more expensive ones. And this is the filter I'm using for a conventional telescope, the daystar quark. There are other ones by Barlow, for example, the Sun Dancer. And of course there are the specialized H-alpha telescopes. I didn't buy one of these because I wanted to use different telescopes with the same filter, which has also some disadvantages. For example, I can't see the whole Sun in one image. These are some nice examples. In the H-alpha you can also see prominences very prominently, sorry for the pun, but also the faculas you can see, and here the prominences are seen from the top. We'll see more examples of that. And these are some special H-alpha telescopes, not something that everybody has or uses. I brought this slide in the introductory video already and explained it there. But once you're using larger telescopes, you will need an energy rejection filter like that one, because otherwise the telescope will roast your gear. And also if you try to observe with mirror telescopes, you need this one, because in a, for example, Schmidt-Cassegrain like this, the f of the main mirror is about 2.2, so here where the second mirror is, you will concentrate considerable heat. That's why you have to block it from the beginning with an energy rejection filter. It's a bit easier for refractors, but refractors larger than say 80 millimeters or maybe 100 clearly need energy rejection filters. So far I haven't tried it with large refractors or larger telescopes. These are my own first experiments, and you may recognize this telescope because it's my dedicated solar telescope. It's from its specs almost perfect, with a 80 millimeters of aperture and an f of 7. And I used a relatively coarse resolution camera, which is ASI 432 mm. Very fast camera, relatively large sensor, but not very fine-grained. But this device has a Barlow inside, which makes a large pixel camera good for it. Maybe I could have chosen a little bit smaller, depending on the scene, a little bit smaller pixel camera, but this was my first try anyway. And the trade-off is, once you're using smaller pixels, you have more pixels or a smaller sensor size. that's the trade-off always in solar observing, because you want to be fast. And in the morning of my first observations I saw something like that, and I wanted to show you because many people have the same problem when they start solar observations. So I was put off a little bit and thought, oh no, now I have to look for a solution of this problem. It will probably take me days or weeks of work. But I knew that some cameras have this tilt plate where you can screw a little bit, and these are gonna vanish. Or there is a specialized tilter that you can screw between the camera and the telescope, and then you can tilt a little bit. So that's what I did, and then it looked like that in the afternoon. So this is a picture where you can see basically everything. You can see a group of sunspots with the flames, which more or less follow the field lines, very nice, and some filaments, and also some protuberances, not very bright, but you can play a little bit with the exposure time, and then you see these very bright, as I will show you in a minute. Here it's the same one, but just overexposed. The surface of the sun is gone, just white, and here you see the large and also the smaller prominences or protuberances. Unfortunately, I couldn't make a video, which I may do at some stage in the future, because of course I did a video, but in a short video you don't see any changes, so you need a longer video and maybe aggregate a couple of hundred images and then again and again and again, which can take you a whole day. And observing the sun is sometimes a bit annoying, because I put off my shoes and my feet were burned more or less because it was so hot at that day in the end of June. Quite special. But it's in a way funny that you observe the guy who did the heat, which is the sun. And this is just one more image. Compared to this one, it's just the other side. And I had a bit of problems choosing my point of view, because with the mount I had to play, and very small changes led to the thing jumping around, so it wasn't very good. It took me quite a bit of time to center the sun, find it again, and look at it, and then say, oh yeah, this is a different part, I'm going to make a video. Here I wanted to show you something which is quite funny, which is this chain of facula vanishing some place here. Of course, the equator of the sun is rather going like this on this image, not like this. And as I told you, the filter, this daystar quark, contains a Barlow lens, which is often a good idea to have more parallel rays entering the filter. Filters tend to be interference filters, as you use in also night time astronomy, but for solar observing often they are tuned, which you don't need in night sky observing. And again, another image, and here you can see there's a gradient which I couldn't solve in post-processing either. So here it's just very bright and here very dark, which is not something you would want to get. I could still play with the parameters maybe and get a better result, but that's the way it is on the first day of H-alpha observing. I called this up a bit of everything, and sometimes here I show subs and sometimes I show processed images consisting of 500 subs or so, and for me the difference is not very large if I use subs or try to aggregate. And this is not something that should happen. Actually, the resulting image should be better, but my algorithms of choosing the best images and combining them are obviously not as good. The image is a bit less noisy, there's a bit less dark spots on it, these kind of dark spots that are not actually here. They're not actually spots on the sun, but they are dust grains somewhere close to the focal plane, probably on the filter. And this is a kind of my nicest example. Here again is this sunspot and a nice filament here, which I tried to improve with a more contrast, and also the facula I like. So for a first shot, this is my best result. And here I tried to demarcate these flames a little bit. That's why I sketched these red lines. And this is more or less the same thing that you see if you have a magnet and iron small iron particles. You can do this kind of thing if you lie your magnet under a plate or something. So this is probably plus pole and minus pole, or the other way around. In the sun, on one hemisphere the minus is leading and the plus is trailing, and on the other hemisphere it's the other way around. And once the 11-year cycle has reached the max and reversed, then this will also reverse per hemisphere, and after 23 years you're back at the same orientation of the magnetic field. Of course, in the minimum you don't see much magnetic fields, and then it starts to drill up, and the more it drills up, the more sunspots you will have, and also the more facles, and also the more flares you will have. And at the moment I record this video a bit later than I made the images, and people, so on the 4th of July, people say there will be 4 or 5 flares today. Tomorrow I will observe the sun again, but with a different setup, just by eye. So I'll see how active the sun is. So there are a lot of next steps, of course, after this first shot of observing H-alpha. Use a better mount for sure, which is a bit difficult. I could use a night mount that is used for nighttime observing, but it's a bit hard to find north. So one solution would be just to find north during the night and then observe during the day, and let the whole thing outside, which I don't like doing as much, especially here in town. On the countryside would be easier, just put a cloth on top of it and nobody's gonna steal anything, but here in town hands are everywhere. I should experiment with flats, because you've seen the dust on images, and with flats I could get rid of this dust spots. Funnily, I've heard, and I've never tried, but I've heard that with solar observing, doing flats is very easy. You just put your telescope out of focus and take some images. Could work. Not with a specialized lamp or anything. The sun is a quite a good lamp. I would like to make films of active zones, maybe also with larger telescopes, like other people do all the time. And I'd like to try out seeing. There are these two types of seeing, local seeing and the jet stream. And there are things you can do about both of them. Actually, I got this from a book I recommend to you in the description of the video by Mark, who is a bit of the god of solar observing, I think. Local seeing you can get rid of by choosing your observing place wisely, which is maybe in the grass or in a region where there's not much thermics around you. Whereas for the jet stream, all you can do is choose which season you're gonna observe the sun. Here where I live at 47 North, summers are good and winters could be good, but autumns and springs are not good jet stream wise, because you have the jet stream on top of you and there's no way of getting rid of that. The seeing is just not very good. I don't know which one is worse, the local seeing or the jet stream. I think it's worth getting rid of the local seeing effects as good as possible, and then if there's still some jet stream, this may not be too bad, I think. But summer can be quite good, and then you can choose mornings and find a compromise between the height of the sun. If it's too flat, it's looking through too much atmosphere. If it's too steep up, the environment is gonna heat up too much. This is the trade-off. So I don't know if 9 o'clock, 10 o'clock in the morning is the best. Probably not 8 o'clock, or maybe in high summer, but yeah, I have to find out. So thanks a lot for the attention, and keep looking up, but not directly in the sun, please. Use equipment, or don't if you're not sure what you're doing. Thanks again.